historical databases. Currently, companies like Tesla and others are working on self-driving cars. These cars use their sensory input to decide which actions to take. And when you take a look at the amount of time that a car is being used at this moment, it's maybe only 5 to 10% of the day. But that's a huge waste of potential, since cars are developed to drive. So whenever a package or a person has to be transported, these cars could receive notifications, and based on their battery level and maybe to the distance they have to travel, and maybe also based on the agenda of its owner, the car could place a bid to drive towards picking up this person or this package. And maybe also his reputation will be sent along with the bid. And if this car is granted this job, the car will drive around all day doing transportation jobs and earn some extra money for you as the owner of the car. But it isn't even necessarily necessary that you're the owner of the car. Why couldn't a car be the owner of itself and become truly self-organizing? Because at this moment, the first moment in history, it is possible for machines like cars to do payments over the internet. Before this, money or digital or currency was always related to people. But with the coming of this digital money like Bitcoin, it's possible that cars do payments themselves. So I can imagine that these cars drive around for themselves. If they have earned enough money, they could buy or place an order for an extra self-driving car that will make even more money for this car. And these cars need to be serviced. Every now and then, maintenance has to be done on these cars. The cars can place maintenance requests themselves on the internet, and they can take care of it themselves. But the difficulty starts when new software updates have to be done on this car. Because what will happen if this software update contains fraudulent software? We have seen in the last few years that there were people that were using cars as a weapon. They drove into crowds of people at the Christmas shopping marts, for instance, in Germany, or at the Ramblas in Barcelona, killing and wounding many people. Maybe in future it's possible for a hacker to hack the software of a self-driving car and turn this car into a weapon. So what we need in the future is that these cars will, every time when they receive a software update, they will ask the other cars, their peers, and they will say, okay, I received this software version. What do you think? Is this a correct one? And if the majority of the other cars, of its peers, will say, okay, this sounds like a valid software update, only then the software update is placed in this car. And if the others say, well, it seems like this is an incorrect version, the software will be rejected and a new software update will be requested from the network. And this requires a sort of consensus between machines. When I look to the future, I imagine a world in which individuals no longer own cars, but cars own themselves. They operate by themselves. They become part of a self-organized ecosystem of machines communicating with each other and in which payments are made automatically via the internet. And these cars will also have reputation systems so that we as humans can see the car is trustworthy. But before we can make an ecosystem like this, we need a certain set, a powerful set of properties before people can learn how to trust these cars or the machines. What we need in the future is a huge amount of transparency. We would like to be able to see which software version a car has. We want to have transparency in their reputation, maybe also the other jobs this car has done. Security is an important aspect. We don't want the software of the car to be hacked, for instance. We need indisputability. If a car shows the reputation it has, we want to make sure that this reputation is correct and that it has not been tampered with. And these cars need an autonomous network so they can talk to each other without interference of people. And we need a lot of trust. Trust in this network, trust in security, trust in this transparency, etc., etc. Well, the technological answer to this is already invented. It is blockchain. In this presentation, I'm going to explain the properties of blockchain, how it works, where blockchain is applied, and what the future with blockchain could look like. Blockchain is the technology behind Bitcoin. In 2009, Bitcoin was invented and made it possible to send digital money to someone else over the internet. If you send a Word document via email to someone else, both of you have got a copy of this Word document. With money, this is undesirable, but Bitcoin solved this problem. Blockchain is also known as distributed ledger technology. A ledger is a list of transactions, just as on your bank account, of all the transactions you have done. And it's distributed because this ledger is copied to all the nodes in the network. A different definition could be a persistent, transparent, public, append-only ledger. And it means that the persistence is that it's impossible to remove transactions from the blockchain. Once they are there, they will always be there. It's transparent. You can look at all the transactions. You could go to blockchain.info and look at the live Bitcoin blockchain and see all the transactions that have taken place from the beginning up until now. It's public. Everyone is able to use it. So you don't have to be part of a company or part of a society. If you have internet access, you can use this blockchain. And it's append only. That means that you can only add transactions to it. You cannot modify them and you cannot delete them. And it's decentralized. And decentralized means that there's not one single owner of the network. So there's no company responsible for this network. Everyone is the owner of this network. In other words, no one is responsible for this network. And there's a consensus mechanism that determines the truth. And that means that if you do a transaction, the network will check if this transaction is valid. Suppose you want to send 1 Bitcoin to someone. The network will check if you have this Bitcoin at the moment of sending this, making this transaction. And then the rest of the network will check if this transaction is valid indeed. And if the majority says it's a valid transaction, only then the transaction is added to the blockchain. Well, how does it work, these transactions via Bitcoin? Suppose Alice wants to send money to Bob, 1 Bitcoin. What she will do is she will make a transaction and send this transaction to the Bitcoin network. In the network, we have these miners. And what miners do is they will collect all these transactions and put them together in a block. Then a difficult mathematical puzzle needs to be solved, which takes about 10 minutes. And whenever a miner has solved this puzzle, the miner will send the block along with the solution to the puzzle to the rest of the network. The rest of the network will check if the puzzle is solved correctly, and if so, the block containing the transaction from Alice to Bob is added to the previous chain of blocks, and from then on, the transaction of 1 Bitcoin from Alice to Bob has taken place. And here you see the name blockchain. It's a chain of blocks that are accepted by the network. And because Bob hasn't spent its Bitcoin yet, the balance of Bob is now increased with 1 Bitcoin. The blockchain is a distributed network. That means that each of the nodes in the network consists of a complete ledger. All the transactions ever taken place are stored on each of the nodes. And it has a great advantage for security reasons. Because suppose you are a hacker, you might want to change all the transactions, even from the earliest days onwards, to send the Bitcoins to your wallet instead of to someone else's. Maybe, if you're smart enough, it's possible to change one of the ledgers on one of the nodes. But in practice, it will be impossible to change at least the majority of all the nodes. So somewhere in time, in the meantime, the majority of the network will find out that your ledger is corrupt, and they will send you a message, and you will re-update your ledger again. And this makes the blockchain 100% tamper-proof. And it's unseen until now in the world of internet. When we look at the blockchain timeline, we can see which developments have taken place. In 2009, Bitcoin was invented, and with it the Bitcoin blockchain. And one of the properties of a Bitcoin transaction is that you can send 40 characters of text with it. It's the same way as when you make a bank transaction. You can send some money to a friend saying, thank you for this delicious meal. And this is interesting because what you could do is, if you make an invention, you could describe this invention in a PDF document, and you can store the hash of the PDF document in a transaction. The blockchain network will validate the transaction, and it will be timestamped and stored on the blockchain forever. And that means that you can always prove that you had made this invention at a certain moment in time. It was later that Vitalik Buterin thought maybe it's possible to store programs on the blockchain. And he built the Ethereum network. And in Ethereum it's possible to store certain programs. They're called smart contracts. And these programs, because of the nature of the blockchain, will always run when one of the functions is called. And they cannot be modified. That means you can make programs that do something and will do this forever. And this will build a lot of trust in your network. The downside of this all is that the Bitcoin and the Ethereum blockchains, they use proof of work to validate transactions. And proof of work is very expensive in energy. At the moment, the Bitcoin blockchain consumes the same amount of energy as a country like Ireland or Denmark or Bulgaria, just to make sure that we have a network in which we can trust. So it was after this that proof of stake was developed, and proof of stake is a different way to validate transactions and costs much, much less energy. Then, with the coming of Internet of Things, we would like to store information on the blockchain about sensors. And there's a problem, because a blockchain transaction, it will take about 10 minutes up to an hour before this transaction is validated. And in Ethereum, it's about 10-15 seconds. But it's still too slow for Internet of Things. And that's when IOTA was invented. It uses a different type of blockchain. It's called the Tangle Ledger. And there it's possible to store many, many small amounts of data very fast. The next evolution was that Hashgraph was developed. It looks a little bit like a Tangle network. The only downside here is that the Hashgraph is not open source like all the others are. Well, let's take a look at a smart contract. What do they look like? This is a small example of a smart contract. And what it does is it's a counter, and you can increment the counter or decrement the counter. There are two functions for this, and you can get the current value of the counter. This is a smart contract. That means you store it on the blockchain, and whenever you call the function, it will always be executed. And it will be executed on each of the nodes in the network. That means you cannot tamper with it, because consensus will take place. Suppose a hacker could hack one of the nodes in the network and change the result of one of the functions. The other nodes in the network will say, based on consensus, that they don't accept this answer. And the answer that was made by consensus will be stored on the blockchain, persistent. This is a very small program. Of course, this doesn't do anything interesting, but what it shows is you can store data on the blockchain, and you can retrieve information from the blockchain. And that's where it gets interesting. When we look at the technical aspects of blockchains, we could say that a blockchain is a distributed storage, because all the information is stored on all the nodes in the network. And that means you get 100% tamper-proof data in your storage. Hackers have no influence on the data. It has an uptime of 100%, and that's because of the huge amount of nodes in the network. And it's decentralized. There's not one single company responsible for this blockchain. It's a smart contract that deals with how data is stored. And that means in the future, if you start developing your programs, you have to make choices about where to store your data. You could store it in an SQL database, like Oracle. You could use a NoSQL database, like MongoDB. Or you could use a graph database, like Neo4j, but you could also use blockchain as a storage. It has certain advantages, but it also has certain disadvantages, and that's something you have to find out in your project yourself. So let's take a look at some examples. The most prominent use cases for blockchain are supply chain, provenance, and identity. The supply chain. If you order an iPhone online, what you do is you will pay the web shop up front. Then the iPhone will be sent to a sorting center. There it will be loaded into trucks or planes or whatever. Then it arrives at a local sorting center again, and then the delivery takes place on at your house. All the time, information is exchanged between the different parties, which could lead to errors. And this is where a blockchain could be useful. They could all use the same smart contract and update the data there. And you can look at the status all the time. And another nice thing is, what you could do is you could pay the smart contract. So you don't pay the web shop, but you pay the smart contract. And only after you signed for receiving the iPhone, the smart contract will send automatically the money to the web shop. And if it takes too long to deliver the iPhone, you could refund the money yourself from the smart contract. And because the smart contract is programmed and will be executed 100% sure, you know for sure that your money is safe there. The second example is provenance, and that's keeping track of the total lifetime of an animal from birth till it arrives in the supermarket for consumption. In this lifetime of an animal, all the different parties could update information. Like the farmer could say when the animal was born, what breed it was. The veterinarian could update which antibiotics were given during the growing of the animal. In the slaughterhouse, you could enter information about when was the animal slaughtered, at which conditions, which temperatures, whatever. And that means that in the end, in the supermarket, you can find out exactly where the animal comes from and which antibiotics this animal has gotten. And that means you can also track and trace whether this animal is, this meat is halal, or whether it has had only bio foods or whatever. And the last example is identity, which is also needed for self-organizing cars. And in identity, you could store your own identity and decide for yourself which information you will send to others, or which information you will allow others to get access to. One example is in the Netherlands, you have to be 18 to buy alcohol. So at the supermarket, the cashier always asks for an ID. But on this ID card, there's much more information than that this cashier needs. The cashier only needs a yes or no, meaning yes, over 18, or no, not over 18. All the other information is not necessary. So at the moment, applications are being built for the blockchain that help companies deliver only or give access to only the information that is needed in a certain process. And now the big question, is this a disruptive technology? Yes, indeed. If you look at Harvard Business Review, here at the bottom of the sheet, it says it's not a disruptive technology, but it's a foundational technology. And that's what it is. It will disrupt our society, for sure, but it's a foundational technology in the sense that it is just as important and just a big change as the invention of internet, and the invention of the computer, and the invention of electricity, because they all made great changes to societies. The blockchain impacts many parties that have been here for years. And one of them is governments. In Estonia, the Estonian government decided to put all their information in the blockchain. And why? Because of means of security. The Prime Minister of Estonia said, I don't mind if information leaks about my blood type. He says, if this database is hacked and people know my blood type, I don't mind. But he said it's much more a problem if my blood type is changed. And that's why he said is the reason we want to switch to blockchain. Because you cannot change records in the blockchain unless you have permission to do this. Banks will change as well, because now it's possible to transfer money without banks. You can store money on different locations than on a bank in a safe way. Supply chains will change, as you've seen in the previous example, and many intermediaries will change. The role of a notary will change, because if you own a house and you sell your house to someone else, the only thing you have to do on the blockchain is run the smart contract that says transfer the title deed of my house to someone else. The buyer will run the same contract and will send its money to the contract, and at the moment that on both conditions are valid, the money is sent to the seller and the title deed is sent to the buyer at the same time. That means for this we won't need notaries anymore. And many more jobs might be gone in future just because of the introduction of blockchain. And which skills do you need if you would like to build blockchain systems? Well, for sure you need business management skills, because you need to be able to develop or describe business processes and look at the business processes with a blockchain view. You need software engineering skills to do smart contract programming and to be able to test and audit these smart contracts. Because once you have uploaded your smart contract to a blockchain, it can never be changed anymore. In other words, there cannot be a single bug in the programming code. And that takes a lot of effort to remove all the bugs and make sure, 100% sure, that your software code is correct. You need to have skills in programming APIs, because that's the way that you connect your user interface, your web interface, to the blockchain. And you need to have a lot of knowledge about databases and when to use traditional databases and when to use a blockchain. And which job opportunities are there? Well, there are many. But at the moment, we need a lot of blockchain consultants who can advise companies on which process to be replaced with a blockchain process, or which blockchain should be chosen, the Bitcoin blockchain or the Ethereum blockchain or one of the many other blockchains. There's Hyperledger, there's R3, etc. We need smart contract programmers, or maybe testers or auditors, because these programs still have to be programmed, these smart contracts. And you've seen the program language, it looks a little bit like JavaScript. And we need business process consultants who could calculate the benefits of switching to a blockchain instead of using an ordinary database. And who can also advise on where should we change our processes. And then in the next 3 years, I've got no idea where it will lead to. I know that this field of work is in development and it's changing rapidly. So maybe in a few years, we just have an easy plug-in for your programs and to say, I don't want to store my data in a database, but I want to store it in the blockchain, and maybe then it's fixed. I have no idea. But I assume that at least the next few years, we need a lot of programmers in this field of work. So hopefully today you learned what a blockchain is. You learned how it works, at least in the basics. You've seen smart contracts and you know what they are and how they can be used to improve our society. Because we need these smart contracts on the blockchain, at least for our self-organizing cars. Because we want to have insight in the various processes they deal with. We need secure storage of the data that they produce. We would like to make sure that everything they do is transparent. And all these developments around blockchain, they all lead to the promise that blockchains give. And that is to deliver trust in a trustless world. Thank you for your attention.